All right, taking a look at 8.5. So in your opener, it says if quadrilateral ABCD has the points that are given there, wants to know would it be a parallelogram? Now remember, to show something's a parallelogram, we can look at opposite sides being congruent. We can look at opposite sides being parallel. We can talk about opposite angles being congruent. But if they're giving me points, I have no way to really work on finding the measurement of those angles. So that's not going to work. I can talk about consecutive angles being supplementary. But once again, I can't really work with the angle measurements. And finally, we can talk about the diagonals bisecting each other, meaning they would have to have the same midpoint. Now, here's the thing about these first two. When we talk about the opposite sides being congruent or opposite sides being parallel, we are talking about both sets needing to be. If I look at my diagram when I plot these points, here's what we have. If I look at my slopes, here we have a slope of 1 over 2. Here we have for AD a slope of 2 over 4, which does reduce to 1 over 2. So I do have BC being parallel to AD, but that's only one set. When you look at your other pair of opposite sides, my slope of AB is undefined. It's a vertical line. The slope of CD is a negative 2 over 2, so I have a slope of negative 1. These sides are not parallel. Right? When you have one set being parallel and one set not parallel, it is not a parallelogram. Instead, we're going to get into that shape today. Instead, this shape here will be known as a trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. That means I have to show that I have one set parallel and one set non-parallel. Now, in a trapezoid, we can talk about a trapezoid having bases. The bases of a trapezoid, they are your parallel sides. Maybe. There we go. The parallel sides of your trapezoid. Now, it doesn't have to be on the top and bottom. I can have a trapezoid instead that has those parallel sides on the left and the right. So here we're looking at AD and BC being your parallel sides. So they are your bases. The base angles, those are the angles that lie along the bases. There are two sets of base angles. They are the two angles that make a base. B and C would be one set of base angles. A and D would be the other set of base angles. Your non-parallel sides, they're known as your legs. The non-parallel sides of your trapezoid. In an isosceles trapezoid, for an isosceles triangle, we said the legs of that triangle would be congruent. An isosceles trapezoid is exactly the same way. It is a trapezoid that has the legs being congruent. So you can have a plane trapezoid where these legs are not congruent. You can have an isosceles trapezoid where your legs are congruent. The last new term there is known as a mid-segment. If you remember, we did a mid-segment of a triangle. A mid-segment of a triangle connected two midpoints of your sides. So that was a mid-segment, or you could take this midpoint and this midpoint. That was a mid-segment. This midpoint with this midpoint. That was a mid-segment. A mid-segment of a trapezoid, there is only one. It is a similar idea, though. It is the segment that connects the midpoints of your legs. So in my mid-segment of my trapezoid, this is the only one that exists. There is only one mid-segment to a trapezoid. Whether it's a isosceles trapezoid or a non-isosceles trapezoid, there is still one mid-segment that you can draw in, connecting the midpoints of our legs. So it says, in your own words, explain the difference between a trapezoid and an isosceles trapezoid. In a normal trapezoid, there are non-congruent legs. In your isosceles trapezoid, the legs are congruent. And that's truly the difference between them. So we're looking, are these legs congruent or not? Okay, let's take a look at example 1. To show that CDEF is a trapezoid. Now, to show that CDEF is a trapezoid, okay, I'm going to give you one, on your chapter test, you're going to have a problem that asks you to show what shape it is. You will get 1 point for your answer. Right? So in this case, they already told you what your answer is. What shape is it? It's a trapezoid. You will get 2 points for your reasoning. What makes a shape a trapezoid? Right? When I look at this, what I have to show is that you have one set of parallel sides. However, that is not enough because the other set could be parallel or not. To make sure it is a trapezoid, you need the other set to be non-parallel. Right? So your reasoning for what the shape is will be worth 2 points. Now, we need to show that that is true here. So you will get 2 points for your measurements. Well, how do we show that we have parallel sides? In this case, we need our slopes. So I need the slope of DE. DE has a rise of 1 and a run of 3. So DE has a slope of 1/3. CF has a rise of 2 and a run of 1, 2, 3, 4, 5, 6. 2 over 6 reduces to 1/3. So I just showed that I have one set of parallel sides. I also need one set to be non-parallel. So looking at the slope of CD has a rise of 1, 2, 3, and a run of 1. 1 over 3, 3 over 1, those are not perpendicular slopes. That's not a right angle because those are not opposite reciprocals, but they are reciprocals of each other. E to F has a slope of, I go down 2 and right 2. Negative 2 over 2 is negative 1. So one set is parallel, one set is non-parallel. Right? So I show the measurements that make that. Overall, a problem like this on your test will be worth 5 points. It'll say show your shape or tell what shape you have. 1 point for your answer, 2 points for your reasoning, 2 points for the measurements to show that reasoning. We'll have plenty of practice here over the next few days. Now, in that trapezoid, if a trapezoid is isosceles, right, Just like in an isosceles triangle, if the legs were equal, the base angles were equal. In an isosceles trapezoid, the same thing is true. If a trapezoid is isosceles, then each pair of base angles are congruent. Meaning angles A and D, they lie on this base. They will have to be equal to each other. B and C lie on this base. They will have to be equal to each other. Now, theorem 8.15 is just the converse to that. If a trapezoid has a pair of base angles being congruent, then it is isosceles. Now, once again, it has to be a trapezoid to start with. So if I know that angles A and D are equal to each other, that would mean that my legs will have to be equal. Or I could have angle B with angle C being congruent instead to start. The last thing about that isosceles trapezoid, a trapezoid is isosceles if those diagonals are going to be congruent. So once again, it has to be a trapezoid to start with. If it's a trapezoid and these diagonals, BD and AC are congruent, that would make it isosceles also. All right, take a look at example 2. So the shelf fitting into a cupboard in the corner of a kitchen is an isosceles trapezoid. Find the measurements of angles N, L, and M. Now, if it's an isosceles trapezoid, the base angles must be congruent. So angle K will have to be congruent to angle N. So since angle K is 50 degrees, angle N is 50 degrees. Now, for your other measurements, remember, these are parallel lines. When you have your parallel lines and your transversal comes through, these consecutive interior angles, these are supplementary. So since this one's 50, angle L has to be 130. Likewise, then angle M would have to be 130 as well. Same math then on the second one. Once again, your base angles are equal. So angle B and angle C will have to be congruent. So angle C is 135. Your consecutive angles here in your trapezoid, those consecutive interior angles with those parallel lines, must add to 180. So angle A will be 45, and angle D would be 45. Brings you to your next idea, talking about these trapezoids. We mentioned the idea of a mid-segment. Now, when we did a mid-segment, we talked about how it connects the two midpoints of your legs. That mid-segment has a relationship as it relates to the two bases. When I look at my bases, if the top base was 10, for example, and the bottom base is 20, your mid-segment is the average of your bases. So I'm going to do 10 plus 20 is 30. The average of it, so I add them together and I divide by 2. So the length of my mid-segment here would be 15. And that is exactly what my theorem says. The mid-segment of a trapezoid is parallel to each base. And then it's half the length, half the sum of the length. So it is the average of those lengths. So if the top base is 10, the bottom base is 20, our mid-segment would be 15. So if I look at my next one, that says in the diagram, MN is the mid-segment of trapezoid PQRS. Find the length of MN. So I'm going to average my bases. 16 plus 9 divided by 2. 16 plus 9 is 25. divided by 2 gives me 12.5 for my length. All right, taking a look at our next shape then, that is our kite. That is our final quadrilateral that we are going to go over. A kite, it is exactly what you would think of if you were looking at an old-fashioned kite in the sky. These two lengths are going to be equal. These two lengths are going to be equal. It is a quadrilateral that has two pairs of consecutive sides being congruent, but the opposite sides, notice these opposite sides, they are not congruent. So it is exactly the old school kite that you would think of that Benjamin Franklin flew. Sure.
You in class?
I'm recording, but that's okay. You can come in.
We just have curriculum night, so we have to hurry up and get in.
All right, couple last things to go over here. In that kite, one property is that your diagonals are perpendicular. So those diagonals, AC and BD, intersect to form 90-degree angles. And then your second property says that there is exactly one pair of opposite angles that are congruent. They are the sets that are in between your non-congruent sides. Right? I'll put this back up there in a sec, but if you look, so if I'm finding my non-congruent sides, the angles made by my non-congruent sides, that would be this angle and this angle. Those angles are congruent in your kite. So there is exactly one pair of opposite angles that are congruent. They are in between the non-congruent sides. So if I look at my next example that's there, it says find the measurement of angle T. Angle T and angle R in this picture, those are my congruent angles. So I'll just call them both X. So 70 plus X plus 88 plus X. In a quadrilateral, they will have to add to 360. So I have 158 plus 2X equals 360. So 2X equals 202. So when we divide, we get X to equal 101 degrees. Same idea, and then the second one. Identify what angles have to be congruent in the picture. So here it is angle G and angle L that have to be congruent. So once again, I'm just going to call each of those X. So it's 85 plus X plus 75 plus X has to equal 360. Combining your terms, we have 2X equals 160. Oh, I'm sorry. 2X plus 160 equals 360 degrees. Subtract it over, we have 2X equals 200. And divide, we get X to equal 100. All right, which brings us to our homework here. Page 546 to 547. Those numbers you see there. All right, please let me know if you have any questions.